Review questions. Electricity and Electronics, 10th edition, Chapter 1. Content by the authors of the textbook, narrated by Hector Bello. Define the following terms. Matter is anything that occupies space and mass and has mass. Element is the smallest component of matter, which retains all unique attributes of a substance. The compound is the combination of one or more elements to make substances of distinct properties. The atom is the smallest part of matter. Molecule is a combination of two or more atoms that provide distinct characteristics. Some definitions may vary according to your source. Name some common elements. Some are sulfur, copper, radon. For more, see periodic table of elements. What is atomic weight? It is the approximate number of protons and neutrons in the nucleus of an atom. What is atomic number? It is the number of protons or electrons in an atom. So to make a difference, to remember the difference, the atomic weight is the number of protons and neutrons in the nucleus. So weight is related to the nucleus of an atom. Remember, the protons or neutrons in an atom make up the atomic weight. For the atomic number, it is basically the electrons, the negative charged particles of an atom, the number of protons, which are the positive, or the electrons, the negative. So it matters not whether it's in the nucleus or not for the atomic number. That's just a difference to remember. What is ionization? When an atom loses or gains electrons, which makes it unbalanced, positively or negatively unbalanced. How does a positive ion form? When an atom loses one or more electrons too many, lacks enough electrons, that is when a positive ion is formed. A negative ion, third question, is when an atom gains one or more electrons too many, or it has too many electrons. So it is negative, a negative ion. What is static electricity? When atoms of a material are positively or negatively ionized, this is, in this ionization or charge, is temporarily maintained statically or immobile. That is static electricity. When atoms of a material are positively or negatively ionized. And this ionization or charge is temporarily maintained statically or immobile. What is a coulomb? It is the measure of current or a collection of electrons in the amount of 6.24 times 10 to the 18th power. What is an electrostatic field? It is the invisible area of distortion or force around a charged body. Again, definitions may vary depending on your source. What is meant by negatively charged body? When a body's atoms are negatively ionized through induction or conduction, that is a negatively charged body. What is induction? It is a transfer of atoms through an electrostatic field. Remember, through induction, things do not touch, bodies charged or not do not touch, and transfer atoms occurs through the electrostatic field, sometimes called the magnetic field. What are the three main components of a simple electrical circuit? First is voltage or power source, second a conductor, and the third is the load, resistance. What supplies the electrons that flow through the circuit? A voltage or power source. Where is the electrical energy converted to another form of energy? This is within the circuit. At the load or resistance or resistor. Like a light bulb converts electrical energy to light energy, or a motor converts electrical energy to physical or mechanical energy. Okay, first question on this page. What two symbols are commonly used for the source of energy of a circuit? First one is E, second one is V, capital. The movement of electrons is known as, the current was already there, the answer, current. Opposition to current flow is called resistance. Opposition to current is measured in what unit of measurement? It's measured in ohms. Again, if you want to try to answer this question before you see the answers, you can either pause the video or be a bit quick and answer the questions before the answers appear in most cases. Electrical pressure is measured in what unit of measurements? Electrical unit of measurement, that is volts. The Planck theory states that electrons flow from negative to positive poles of a power source. Again, from negative to positive. That is the conventional theory. As opposed to the theory of electron flow. When the polarity of the circuit is important, what current flow theory is being used? I may have just gave you the answer. That is the electron flow theory, from negative to positive flow. What type of current flow, or what type of current flows in only one direction? That's direct current or DC. What type of current alternates direction on a cycle? Alternating current or AC. What type of circuit provides only one path for electron flow? It is the series circuit. What type of circuit provides more than one path for electron flow? That is the parallel circuit. What voltage is needed to produce a current of 2 amps through a resistance of 6 ohms? If you would like to take a minute, do the math, pause the video. But using Ohm's law, which you should know like the back of your hand, voltage equals current times resistance. So voltage equals 2 amps times 6 ohms equals to 12 volts. When 12 volts are connected to 4 ohms, the current equal to blank flows through the resistance. What is the answer? Take a minute to work that out. Remember Ohm's law. Ohm's law has a few ways to write it. One of them is I equals E divided R, or current equals power divided resistance. So current equals 12, in this case 12 volts divided 4 ohms, which equals 3 amps. A resistance of blank produces a current equal to 8 amps when connected to a 24 volt. So we're looking for resistance in this case, so we rearrange Ohm's law to R, or resistance, equals E voltage divided I, or current. So resistance equals 24 volts divided 8 amps equals 3 ohms. How many volts does 4 kV represent, or kilovolts? Kilovolts equals 4,000 4,000 volts. Remember, 1 kilo is 1,000, so 4 times 1,000 is 4,000 volts. What is 8 mega ohms? M, capital M meaning mega, millions, equal to in kilo ohms. Kilo meaning thousands. So since K equals 1,000, move decimal point 3 zeros to the left. So moving the decimal point 3 zeros, that is not the left but the right, and you get 8 million kilo ohms. Excuse me, 8 million ohms. since 8,000 equals 8 kilo. So 8,000 times 1,000 equals 8 million. Write 3 millivolts as a decimal unit of voltage. So M, that is small m, equals to milli, which equals to 0.001. So 3 millivolts is the same as 0.003 volts. What we gotta do is divide by 3 divided by 0.001. Excuse me, multiplied by 0.001. One millivolt is how much larger than a microvolt? 1 millivolt equals to 0.001 volts. So therefore 1 microvolt equals to 0.00001 volt. So if 0.00001 volt equals 1 microvolt, then 0.00001 volt times 1000 volts equals to 0.001. So 1 millivolt is 1000 times larger than 1 microvolt. How many milliamps are there in 20 amps? Since 1 milliamp equals 0.001 amp, and 1000 amps times 0.001 amp equals 1 amp, then 20,000 amps times 0.001 equals 20 amps. So 20,000 milliamps are there in 1 amp. 3 millivolts as a decimal unit of voltage. Write 3 millivolts as a decimal unit of voltage. Shown there already. M equals milli, small m equals milli, equals 0.001. So 3 millivolts equals 0.003 volts. 1 millivolt is how much larger than 1 microvolt? Remember, millivolts is 1,000th of a volt. Microvolt is 1 millionth of a volt. So 1 millivolt again equals 1,000th of a volt. 1 microvolt equals 1 millionth of a volt. So 1 million times 1000 equals 0.001. So 1 millivolt is 1000 times larger than 1 microvolt. If 5 times 10 to the negative third, or to the negative 3 power, is 5 times 10 to the negative third power larger than 5 times 10 to the negative 6 power? That is a question. So I would say yes, because it's closer to the 0. It's a larger number. It is said to be a larger number, not necessarily longer, just larger, because it's closer to the 0 in the number line, if you visualize it like that. But you can also say 10 to the negative third equals to 0.001, written down in just decimals, no power. So 10 to the negative 6 equals 0.00001, which is further away from the 0, less zeros after the decimal, equals the number closer to a whole number. So it is a bigger number. The less zeros to the right of the decimal equals a larger number. So yes, 5 times 10 to the negative third is larger to 5 times 10 to the negative 6. Express 6 times 10 to the negative 6 with a symbol or prefix. So that would be 6 microvolts. An electron displays a or an blank charge. A proton displays a or an blank charge, and a neutron displays a or an blank charge. Answer: an electron displays a negative charge, a proton displays a positive charge, and a neutron displays a neutral charge or no charge. What is the name of the electrical base unit based on the number of electrons? How many electrons does it represent? It is the coulomb, and it represents a number of 6.24 times 10 to the 18th power of electrons, number of electrons. What are the two laws of electrostatic charges? Oppositely charged bodies attract, and like charged bodies repel. In simple terms, the force behind electron movement is called voltage or electromotive force or EMF. When an atom loses an electron, it becomes ionized. The invisible lines of force that surround a charged body is called electrostatic field. What causes ionization to occur? When EMF causes electrons to be released from atoms. Remember, it could be either pushed away from atoms or attracted into atoms. Matter is found in what three forms? Liquid, solid, or gas form. Matter is found in one more form. Can you name? Plasma. The smallest part of a compound is called a or an element. What are the three basic parts of a circuit? Source, conductor, and the load. Also, sometimes a switch is included as a basic part of a circuit. Which part of the circuit converts the electrical energy to another form of energy? The load. Which type of fire extinguisher is used for electrical fires? Type C extinguisher. Which part of the circuit provides a current path? The conductor. Write 16,000 volts with a prefix 16 kV. Write 0.005 volts with a prefix 5 millivolts. Write three forms of Ohm's law. You know those by now. The way I remember it is that voltage is, for the most part, or if not all the time, the larger number that needs to be, it needs to end up as a larger number. So in the first mode, which is probably the more familiar formula or equation, where power equals current times resistance, power is on the left side, and it's more or less going to be the larger number, since the two on the right side are being multiplied to give you the number on the left side, which is your voltage. So you pretty much, most of the time, it's going to end up being a larger number. Again, power is going to end up being a larger number. That's again a way I can remember Ohm's law quite easily. And in this case, current is on the left side of the equation. Then if power needs to be the larger number, you usually want to divide the larger number into you want to divide the smaller number into a larger number. So E is divided by R, which is usually a smaller number. R is. And the third case, where resistance is on the left side of the equation, again, you want to divide the larger number, which is power, E, divided by I, which is a smaller number, to give you your resistance. So as far as you think about power as being the larger number, I think it's a lot easier to know where its place is according to what you're trying to find. Again, what you're trying to find is your number or letter on the left side of the equation. That's the goal of the equation, the one on the left, for the most part and conventionally. How much voltage is required to force a 3 amps through a resistance of 36 ohms? Again, how much voltage is required to force 3 amps through a resistance of 36 ohms? Again, your Ohm's law, voltage equals current times resistance. Your current is 3 amps, your resistance is 36 ohms. Multiply those and you get 108 volts. How much current will a 24 volt resistor connected to a 6 volt source? Again, how much current will you get? So that your current is your problem, or your X if you're talking algebraic terms. So how much resistance is present? Again, this question is probably not written right, so I'll double check it. You're looking for current. The question is, how much current will a 24 ohm resistor connected to a 6 volt source give you? So you're looking for your current, put I on the left side, bigger number E divided R. So 6 volts, that's your source, divided into 24 ohms. See here, your E ends up being smaller than your resistance, but if you think of volts and resistance, 24 ohms is nearly nothing, nearly no resistance. If you know a bit about resistance, 24 is very small as compared to volts. 6 volts is not as such a small amount if you think of voltage and resistance, instead of thinking of just plain numbers. So your current will be 0.25 amps, or a quarter of an amp. Next question, a meter indicated 5 amps in a simple circuit connected to a 12 volt source. How much resistance is present? So we want to know the resistance, so we put R left side of the equation, and E divided I, or voltage divided current, on the right side. So we plug just the numbers in, voltage divided the current, 12 divided by 5 equals to 2.4. That is your resistance in ohms. How much current will a 12 volt car battery produce when connected to a lamp with a 600 ohm resistance value? Again, we're looking for current. So we put I on the left and E divided R. That's your Ohm's law formula or equation written to solve for I, or current. So power, 12 volts divided 600 ohms gives you 0.02 amps. Again, the next question is 5k ohms or kilo ohms resistance is connected to 100 volt source, and it will produce how much current? Again, we're looking for current, so we place our Ohm's law formula with I on the left. Your voltage is 100 and your ohms or resistance is 5,000. 5 kilo divided gives you 0.02 amps. Again, same answer as the problem before. So you can see the relationship between resistance and volts. That is why they're doing this. A 6 volt battery is connected to a 240 ohm lamp What is the expected amount of amperes produced by this circuit? Again, looking for currents, and we're doing all these current exercises to help you visualize better the relationship between resistance, volts, and amperes. So 6 volts divided 240 ohms equals to 0.025 amps. Pretty close to the other two. If you can just step back and take a look at all of these three problems, you would notice that you get about the same amperage, very close to the same amperage, using different combinations of voltage and resistance. In the first, you use a 12 volt with a 600 ohm resistor. You get 0.02 amps. Second problem, you use 100 volts into 5000 ohm resistor. You get 0.02, the same amount of amperage. So you increase your voltage, you increase your resistance, you get about the same current. Again, if you relatively increase your voltage and your resistance, you will get the same amperage. Same thing going on in question number 3. We're using 6 volts and 240 of resistance, and you get about a bit higher amount of amperage. And compare question 1 and 3, where you have 12 volts, and in number 1, question 1 here on the page, and question 3 you have 6 volts, about half, and you are basically using about half of the resistance from number 1 to number 3, like 600. Half will be 300, but you're using about 240, which is a little less than half, and that's why you have the slight difference in your answer for amperage. You have a little higher amperage than your the amperage in number 1, question number 1. It's a little higher for number 3 than for number 1. So looking at these, you can start to appreciate the relationship between amperage, current, and voltage. Once you get the feel for those, what they are supposed to be, once you get familiar with the different voltages and resistance values and what kind of amperage they produce and vice versa, then you'll begin to understand a lot more the formula for Ohm's formula, or the Ohm's equation, and you'll recite it just like you recite your name. Next question is, how much voltage is needed to produce a current of 5 microamps through a resistance of 1 kilo ohms? Again, Ohm's law, we're looking for voltage, so we place the E on the left side, I times R, and we plug in the values for current, 0.0005 or 0.00050 divided 1000, and that'll give you 0.000005, and that is volts. That is the amount of voltage you need to push 50 microamps through a resistance of 1000. Notice that you hardly need any voltage. It's a very small amount of voltage to push through that type of resistance, which is very small. That is a very small amount of resistance and current. So you need not a lot of voltage. Therefore, you get that small number, which is 0.000005 volts.